Hello and welcome to week 11 of Introduction to Data Science. This is our last Keeping Up with IDS video. Last week was about model validation and uncertainty quantification. We introduced a new technique called cross-validation, which is very widely used, especially with predictive models, where you start with your training data, setting aside your testing data and not touching it until the very end, and working with your training data, set aside parts of it at a time and fit your model to the remaining bits, and then cross-validate across these folds until you're happy with the model that you've selected or a couple candidate models that you've selected, at which point you then get to touch your testing data. And we exemplified this approach over 2 application exercise videos working with the data from the show The Office. We also talked about this notion of quantifying uncertainty around our estimates and basically talked about bootstrapping as a method for doing so. There were a couple questions from the quiz this week that came up as still maybe sticky topics. One of them was about the definition of RMSE, which is basically root mean squared error. So when we're calculating RMSE, what we're doing is we are doing a prediction with our model. And so for each of your X's, your observations in your data set, you make a prediction, and that prediction is basically your Y hat. We also have our Y's, our observed points, or observed data for the outcome variable. And the difference between these is called either a residual or the error. So that's going to be, if we have a scatter plot, kind of those vertical lengths that we've seen before. And our goal in general is to minimize these, but we usually think about minimizing the squares of these. So what RMSE does is it basically squares all of these values and sums them up and then divides them by the sample size. And hence the idea root mean squared error, we then take the square root of that whole thing. And because we take the square root at the end, initially those errors, so those distances are squared, and then you're taking the square root at the end, so you're back to the units with your original data set. And that's the reason why we're able to take a look at the magnitude of our RMSE and then compare it to the variability or the range in our original outcome variable in the observed data to see, does it look like we're doing somewhat of an okay job, where how off we are on average is much smaller compared to the range of our data, or are they roughly the same size, in which case you're basically saying you could be all over the place. So the answer from the quiz question about RMSE that was false is that RMSE ranges between 0 and 1. That's not true. We do prefer lower RMSE values, but remember that the unit of the RMSE is the same units as your outcome variable. So if your outcome variable is housing prices, then all the values are going to be large numbers, and hence the root mean squared errors are going to be large numbers as well. It's R squared. That's a value that's between 0 and 1, which is another measure of checking model performance. And similarly, your area under the curve is also a value between 0 and 1. For another question on the quiz was on just a simple linear regression output, and it seemed like here the tricky bit was about whether the units of the correlation coefficient or the slope estimate would change if we change the units of our measurement. So here we were looking at predicting heart weight of cats in grams from their body weight in kilograms. And one of the 2 choices that were about units read, the correlation coefficient would not change if body weights were measured in pounds, or the slope estimate would not change if body weights were measured in pounds. The correlation coefficient need not change because that is a value also between 0 and 1 and is entirely unitless. While the slope, if you remember, the interpretation of the slope is each additional unit, or for each additional, unit increase in X, we expect Y to change on average by this much. And when we say by this much, we're looking at a value that's measured in the units of your outcome variable. So in fact, if we're thinking about changing the units of measurement, we are going to be changing the slope as well. Another example of this could be about, let's say your how much you train and how fast you get if, say, you're training for a marathon. If you train an additional hour versus an additional month, obviously you would expect the effect of that on your performance on the marathon to be a lot different. So that's about the units of measurement changing, and we're talking about the slope there. All right, so this week we've asked you what you want to learn about, and I don't know if the results were more of a feature of the order in which I listed these things to begin with or not, but basically the choices seem to be that the top choice was about to hear something about machine learning, the next one was interactive web apps, and then text analysis, and there weren't as many takers on Bayesian inference or building R packages. So in fact, we are going to talk about these top 3 this week, and we're going to build on the data scraping exercise we had learned about a few weeks ago, where we took a look at the COVID-19 speeches from the First Minister. So we'll work with the data that we have already scraped, but we'll actually work with the text data to learn a little bit about text analysis. We're going to use that same data set to build a simple interactive web app in R, and then we're also going to use the same data set to build a predictive model. So that's what's on offer for this week. Usually week 11 material is quote unquote not examinable, but we don't have an exam in this course. So what that means in your case is that there's no expectation that you incorporate anything we're learning today in your projects that's due tomorrow on Friday. If you do, that's obviously entirely up to you, but there is no such expectation. And already your project is very open-ended. So what it means that there's no such expectation is that even if looking at your data and your research question, the obvious choice would have been to do something that we talked about this week in terms of evaluating your work. We're not going to think about that as an obvious choice. We're going to assume we never cover that material going into your projects. That being said, your quiz that's going to be due at the end of this week, which is going to be the last quiz, will cover material from this week. And finally, your homework that's due next week will also have bits and pieces from this week, but it's going to be lighter on this week's material and a bit heavier on previous weeks. So this week, really what we're asking of you is there's that thing you're seeing for Tuesday called progress. Well, what that really means is that we hope that you have made some progress between last Friday and today. And so I really put that on the schedule for you to have a mental check with your team. It's a great day to meet with your team. We have student hours that morning with David as well that you might choose to meet at that time and kind of go over where you're at, take a stock of what else you want to accomplish before the due date for the projects on Friday. And the important thing about Friday is not only are your projects due, but they're due at 10 a.m. UK time. So it's at that time that I'm going to take away your access from your repo, so you won't be able to push to it anymore, which means that you need to make sure that you get if you're doing a pre-recorded video, that you get your pre-recorded video there. If you're going to be presenting live, that all of your slides are finalized there as well. On Saturday, we have a peer evaluation due, and that is a mandatory, if you will, peer evaluation. So that's going to be where we ask you very specifically about the workload distribution for your projects. And in order to get the peer scores for yourself that your teammates have given you, you must turn in a peer evaluation. So that is our carrot and our stick for making sure everybody does their peer evaluations. The reason for that Saturday deadline is I wanted to give you a chance to actually finish everything up on Friday and not add another deadline later in that day. So should you forget to fill that in by Friday, you still have an additional day. But again, if you don't turn in your peer evaluation, you won't be able to get your scores for it, which would mean effectively losing some points on your project. So it's really, really important that you do that. And finally, our last quiz is due on Sunday by the end of the day as usual. There's only one more official deadline after that, which is next Thursday, your homework 5, which will be posted a little bit later today. And as I said, we'll cover mostly the end of the modeling material and also a little bit from this week as well. Well, I hope to see you at the live sessions and very, very much looking forward to your projects on Friday. Have a good rest of your week.